Hi guys, my name is Manish Kumar. Today we will work to create system design of Google Map. So what is Google Map? So this is a mobile app which help user to navigate from given source to destination with a smooth map rendering. And Google has started in 2005. So basically how it works, people use this on mobile data. So the key challenge here in front of Google was to make it in such a way that it should use minimum data of user phones. So in today's session, we will see how to render map with minimum data uses. It also provide information like live traffic conditions, alerts, and shortest path. And most interestingly, ETA. So to keep you engaged, what I did, I have recorded this entire session in 3 videos. In the first part, we will talk about functional requirement, non-functional requirement, we will do capacity math, and we will create a high-level system design. And in the second part, we will deep dive into this, where we will pick each service and we will talk more about it. We will explore different APIs for those services. And I created a third part where we will be majorly focusing on ETA service and we will utilize machine learning concepts in this. So this will be one of our most interesting system design, guys. Lot of learning. So without wasting time, let's start the session and see you in the session. So without any delay, let's start the session. So our step 1 is to collect the functional requirements. So functional requirements. Here we actually try to understand what our system will do from this video point of view. So it should be able to help user to navigation from source to destination. So user enter address, it takes the location and help navigating to, in which it will be doing map rendering, route rendering, and we will also talk about ETA, the estimated time arrival. And we will keep out of scope services like different transport modes will be out of scope, and alerts the traffic conditions. So we will keep them out of scope from this video point of view. Our major focus will be user should be able to enter the address, system should render a map, it should help in navigation taking that user to the destination, should show how much time it's gonna take, what time user will arrive there. So that will be the key focus in this system design. So our step 1 functional requirement seems pretty reasonable. So let's move to second step, and that is NFRs. So NFRs, definitely it should be highly available, scalable, and it should provide a smooth navigation and least data uses. That's gonna be very interesting in this case, that it should use the least data. So seems like, I think, pretty good from non-functional requirement point of view also. Then let's jump for the third step, that is capacity math. So what is capacity math? So we have 1 billion daily active users using it for 5 minutes daily. We are just making certain assumptions so that we can do certain maths on this. So 5 minutes daily, and let's say system collect road data from a third party service, and we can just have an estimate for this also, like that 5 terabyte of road data we have. So system uh, is storing map data, and map data is like tiles, which is 256 by 256 pixel. So we need to little bit talk about geohashing here so that you can understand how with the tiling and geohashing works. So let's talk about geohashing here. So think this is a two-dimensional image of entire earth map. At a different zoom level, a different information it stores. So when user is like at the top level, it stores the entire earth as a single image. So this as a 256 by 256 pixel image. So if you are like interested to see the entire map, user can, it will just download one image for the user and user can see the entire map. But here it has a different information at different zooming level. So maybe at the entire map it might show the big countries names on the map, and now further recursively it breaks it down into further small tiles. Like if you see here, it has a segment into equal 4 parts and gives the unique ID for each tile. So here it is giving 01110010. It appends the two binary number. Further it breaks down the first tile into 4, so it appends two binary number to each tile to give them a unique ID. What it does, it keeps breaking down until it reach up to a particular size of the grid. For example, at the zoom level 20, when it is split it further down onto 20 zoom level, the size of grid becomes like 39 kilometer width and 20 kilometer height. So because it's continuously appending two binary numbers, so when you keep zooming in and breaking down the entire map, so this binary number continuously grows up and it becomes a big number. So what it does the base 32 hash on this number so that we can have a reasonable length of the IDs for each grid. For up to 10 digit, it's the base 32 length becomes only 2. So now we have a reasonable size of the ID to store in the database for all the grids stored at different zoom level. So it has like one is like for entire earth, one grid, one ID. Then it further break down into first zoom level where entire earth is broken into 4 parts, and then further each grid is broken further down recursively. So if you will see a little more how it looks like, in the first level it looks like something like this. The entire earth is here and you can see the bigger countries name are appearing on the picture. Now further user zoom in. So I took this picture like from my phone. So this is blue dot you can see is like my location appearing on the graph. When I zoomed in onto the United States, you can see all different state information appearing now, which was not in the first screen. First screen was like just showing the United States here, and the little border lines was there for each state if you will see closely. But on the next zoom level, you can see the state name started coming now, and it's showing my location also as the dot. Now if you further zoom in this, then you can see like it's like reaching out to my location. Here is my location, and you can see in this section what I highlighted in this rectangle, that it's showing more street information. Now the lines are like these are streets, and these are like big streets. Highways are like more thicker lines and darker lines. Then you can see the light gray lines over there, which are the biggest streets near my location. City names, the biggest Allentown and Donneville, like these city names also appearing on the map now. And if you further break it down or further zoom in, then you can see from this image to this image, where from left image to right image, if you will see in the right image, we have like more street information, lot of like very small streets started appearing on the map. So basically what it is doing, it's recursively splitting down the entire grid into further smaller grid sizes, but in each zoom in level it is putting additional information into that. Start right from the beginning where only country names comes. When further zoom in level, if you will go down into the next zoom in level tiles, you will see the state names, and further down then streets start coming, and then the small streets comes. So at each zoom level there are different set of information stored in the each tile, and so that user can easily see zoom in and zoom out, and it can show the more relevant information for that user, because that does not make sense to show the all small street everything in the map when user want to see the entire earth. And when user go on a particular country there, if it is her own country, then they might want to see the location dot over there. So that was the idea on this screen, where they showed like, okay, here you are the Pennsylvania state, but this is entire country and different states located on this map. So that's how it works. And this entire information, if you will see, I just further zoomed in, you can see on this right side big image all the street name appearing now, and this is I think the zoom level 20. Tiles at different zoom levels are stored, and it's something like this. I just have a rough calculation over here. You can see at the zoom level 0 there is just one tile considering the entire earth, then zoom level 1 the 4 16 64, and at zoom level 20 there is almost 1.1 trillion tiles over there. And if each tile size, each picture size is 100 kilobyte, then the total size at zoom level 20 will be 1.1 trillion into 100 kb, which is like 100 petabyte. And the 90% of images are like just mountain, lake, oceans, where no roads or no navigation information required. So if those are like removed out from it, it will be approx 10 petabyte of data to store the entire earth map, all the tiles at different zoom level. So if you sum them up for each zoom level 10 petabyte and then do calculation, it comes out to be 15 petabyte of data. So we have the 15 petabyte of data where all the map information got stored. So here the map data will be 15 petabyte and it will be stored in CDN because we want a quick delivery of this for the applications. So now we have the road data, which is 15 terabyte of GraphDB. It will be like intersections will be nodes and road will be edges. So, and we have 15 petabyte of map data, which we will store in the CDN, these images. Now, the third thing comes is the location data. 1 billion user, 1 into 10 raised to power 9 user are using it for 5 minutes daily, 5 into 60, which means 300 billion requests coming for the location data in a day. And if let's say rather in every second, it goes in the 15 seconds every time, so it will be around 20 billion requests. And if we try to find query per second, so 20 billion, which is 10 raised to power 9 in divide by 24 into 60 minutes into 60 seconds into 10 raised to power 9 divide by 10 raised to power 5, which means 20 into 10 raised to power 4. It comes out to be 200,000 query per second. This will be our location data throughput. Now, what will be the size of location data? So location data will be storing, what it's gonna store, it will store ID, the user ID, timestamp, and lat long. If we say it's 1 KB data, so data size will be 1 KB into 20 into 10 raised to power 9, right? This will be the data coming per day. So it will be 10 raised to power 3 kb is MB, 6 is GB, and 9 is TB. So it's 20 TB data per day. So this will be continuously growing DB. And we need highly available. So Cassandra seems to be a best suitable option for this. So now we have Cassandra for location data, map data, all the images are stored over CDN, and the graph DB is used for the road data. And road data and map data is kind of static, which is like, not so frequently, and location data is like continuously growing DB. And we need the location data information to be served in the various sub applications. Like, we are not covering the traffic conditions, but if the service will be there for traffic conditions, this data will be used for that too. So now we have the functional requirement, we know what our system gonna do, we know the non-functional requirement, and we had a high level capacity math. So I think we can now make a high level design before we come back to APIs, or maybe we will talk about APIs as the different services comes up. Okay, so we will begin with the user. Here is the user, and user will there will be a navigation service which actually use the DB the road data. So it will use the road data, the graph DB, and it will find the right route for this given user destination, and then there will be location service which will continuously be getting location information and storing it in a Cassandra DB here. And then we will have a ETA service. ETA service will use the location data, input road data as input, and will send back the estimated time for the user. And then there will be CDN and S3 drive. So the images are stored over here in the S3, and using CDN it will provide the images, the map images to the user. So if you will see at high level, here user enter the information of the source and destination, and system send the request to navigation service. Navigation service provide the route data and the map data, and then the application download the map images from S3 drive and show it to the user. And now user app, the client app, will continuously be sending location to location service. Location service is storing that information and sending that information to navigation service. Navigation service is continuously evaluating the correct route and like providing it to the user. And there is separate service running ETA service providing the estimated time. So we have this high level design at least covering all the functional requirement, guys. In the next video we will start talking about the non-functional requirements.